Good morning, everybody. How are you? Hope that you're doing well. Why is my video locked up on my screen? That is weird. Are you guys able to see me on video? I'm seeing a locked up view on my end. What is going on there? Give me just a second, guys. For some reason, my video is locked up. Yeah, frozen image. Thank you, Rex. What is going on there? Oh, that is terrible. Hey, guys? Give me just a second. How can I fix that? I've never had that go bad before. Oh no, that's gone completely bad on me now. Well, guys, this is what I get for taking a break, huh? All of a sudden, my camera doesn't want to work. Give me just a second here, guys. We're going to have to try to fix this on the fly. All right, give me a second here, guys. Let's... Oh my, All right, guys, give me a second. My camera died out for some reason. Have you tried turning it off and back on? Ha ha ha. Guys, for some reason, my phone died. The phone that I use as a camera died. That's crazy. That usually doesn't happen. So give me a second here, guys. That is looking like it's back. Why would that have stopped, though? I have it connected at all times. And it was working earlier. Give me just a second here. All right. Let's see if that fixed it. Fix it. Oh no, this is going to be terrible, guys. Oh my, what am I going to do here? All right, guys, I think I'm going to have to restart my OBS. I don't know if that shuts off the stream or not, but we're going to have to try it. All right, I'm showing it back on Instagram. It looks like YouTube is starting to come back. What do you guys think? Let me know. Give me some feedback in the chat. I think we should be back to being okay. Okay, video's back to normal. Thank you, Danielson. Okay, working. Looks nominal. Look at Rex pulling at the big words. Nominal. Okay. All right, so it looks like we're back to good. Sorry about that, guys. But hey, that's one of the risks of doing live video, right? Sometimes things are going to go well, sometimes they're not going to go so well. But how are you guys? Good morning. It's good to see you guys again. It took a little bit of a stream break. I've been gone for a week now, something like that. And look at all the problems we're having. That'll learn me to not take breaks, right? That's what you get for taking a break. I hope you guys are doing well. Thank you so much. Glad to see you filling up my chat here with everybody, all of my regulars. And if you're new, that's okay too. We get lots of new users, so welcome. It's Sunday, which means that we're going to continue our series on building a project. Well, every Sunday we have a series. We just happen to still be in this series about building a project. So glad to see all of you are back. I missed you guys. I missed spending time with all of you on stream. So hope that you are well. I took a little break, to spend time with my parents, celebrate Thanksgiving here in the US. Spend some time with some friends. Got caught up with one of my good friends on Friday afternoon. So that was really nice. And really just trying to, get myself ready for December, get ready for a great month ahead, get ready for 2025. It's already December 1st today, which is incredible. It means that before you know it, we'll be talking about the end of the year. So that's incredible too. And looking forward to 2025, right? That's the next big thing I think on most people's schedule, right? How do you get to 2025 in one piece and start achieving some goals, right? But hey, like I said before though, don't forget, December is still here. December is still 8% of the year. So don't put off things until 2025. Get after it now, right? Get after some of those goals, some of those things you want to study, some of those things you want to do. Now is the time. Now is the time to get started. All right, guys. So if you're new, feel free to say hello. You're probably not the only new person. We still get a lot of new people. I'm seeing people over on Instagram, so feel free to say hello. I'm pretty sure my chat is still working, so I should be able to see chats from all of you. And then before you know it, we'll start getting into the content. I think we got a lot of interesting stuff to cover today. Today we're going to talk about stuff that they basically never teach you in school, right? And I think we've been doing that the last couple of weeks. So we're going to keep after it. We're going to just keep on having some fun today, okay? All right, so let me look at my chat. And I know that there were some of you who put chat messages before. Unfortunately, I had to lose those because of my reboot. But yeah, we're glad to see people already in the chat. So feel free to say hello if you'd like to. First, I want to call out Reese Gaming God. Thank you so much for being one of my members. If you guys see the special icon next to Reese's name, that means he's one of the members of the channel. So really appreciate your support, Reese. Thank you so much for that. Really hope that you're getting a lot of value out of the content, but thank you so much for being a member of the channel. So Reese says, good afternoon from South Africa. Good afternoon to you too. Hope you're doing well. Hope everything is good out there in South Africa. Lots of viewers from South Africa and the African continent. So glad to see that you're here. And anything we can help you with, let us know, Reese. But glad to see you. And again, thank you so much for being a member of the channel. All right, so Michael, our friend from Nigeria, says, nice wallpaper, Dennis. Sunday blessings, everyone. Yeah, I had to have my phone wallpaper up for a minute. It's pretty annoying how OBS handles this, where sometimes it'll show this. When it doesn't show the camera, it'll show the screen of the phone. So I have my dog up as one of the wallpapers. But yeah, it can be really annoying. But thanks so much for being here, Michael. Good to see you. Denelson, our good friend from LA, says, yes, the video is back to normal. Thank you, Denelson. Hope you're doing well out there in LA. Lakshmi, our good friend Lakshmi, says, hi, Dennis, it's working now. Thanks so much for that feedback, guys. Hope that you're doing well out there, Lakshmi. Rex, my most dear moderator, says, looks nominal here on Twitch. So thank you, Rex. Appreciate all your help. Hope you're doing well out there in New York City. Osama, our friend from, I believe, Satat. Hello, sir. I hope everything is going well. Everything is going very well. I've had a good break. Like I said, I got caught up with family, got caught up with friends, ate some good food, ate a lot of food, because I was with my parents, and your mother always feeds you well, right? So I was with my parents, really had a good time out there in LA. My dog also had a good time. You know, he was out there running around and everything. Yeah, so we'll see. We'll see when I get to see them next, but the day's going well. Denelson says, good morning, Dennis. So glad to see you back. Hope you had an amazing break. I did. Thank you so much. Hope you had a good Thanksgiving too. I hope everybody in the U.S. had a good Thanksgiving. I had a very nice Thanksgiving, you know, got to do some good food. You know, maybe I was a little bit off the diet for a little bit there, but I gotta get back on it. Gotta get back focused. So I'm working on that today. I got my soup cooking and I get to spend time with all of you. So it's going to be a good day, Denelson. Michael says your beard is back as well. Hope you've been doing well, Dennis. Yeah. Give me some feedback on the beard, guys. I'm thinking about growing a winter beard over here. I don't know. I've had them before. It's more convenient than shaving every day for sure, because shaving every day is a pain. But I don't know. I think it makes me look too old when I have the beard. Let me know what you guys think. Give me some feedback in the chat. I might post a poll on Instagram later. You know, beard or no beard. I don't know. We'll see. You know, this is only like a week's worth. Like I haven't shaved since I spoke to you guys last. So this is what it grows in a week. So it grows pretty fast. Like, you know, in another week, I'll have a full beard, right? But I've already started training it because if you don't train a beard from the beginning, it gets out of control, right? But yeah, you know, I don't know. You guys let me know if I should go beard or not. Joseph, how are you, Joseph? Happy Sunday, Dennis and everyone. Happy Sunday to you too, Joseph. Hope you're doing well. Starry Vibes, our good friend Starry Vibes is back. Hello, sir. I hope you're doing well. I'm doing very well, Starry Vibes. Hope the same for you. Hope you're doing well out there. Manoj, good morning, Sir Dennis and everyone. Manoj from Bangalore, India. Manoj, so glad to see you. Thank you for being here. Really appreciate you. Really appreciate everyone's support. So really glad to see everyone. You know, if you guys want to let me know what happened this week, we haven't talked in a week. It feels like it's been forever, right? But last Sunday, I think, was my last stream. But as I promised you guys, I'm trying really, really hard to not have any breaks in the Sunday series. I know how many of you like the Sunday series. I enjoy them too. You know, I like putting the materials together and then, you know, kind of talking things out with you. So hope you guys are enjoying it and not going to interrupt it as much as I can, right? I might take a Sunday off or two going into the new year. Don't know, you know, because a lot of holidays are coming up here in the US. But we're just going to try to keep on meeting every Sunday as much as we can, all right? So again, if you want to introduce yourself, you know, now is a good time for it. Otherwise, I just have a couple of notes to share, and then we're going to get right into the material. So feel free to say hello if you'd like. But there's two things I want to share with all of you. One, I have a really good series coming up in December. In fact, it's going to start tomorrow. I'm going to publish the first video of that series tomorrow. And what I'm going to do is I'm going to take my own money, my own real money, and I'm going to invest it according to an AI algorithm. AI wrote the algorithm, and I'm going to use the algorithm, and I'm going to follow whatever the algorithm tells me. I'm not going to make any decisions. I'm going to do what the algorithm tells me, and I'm going to invest real money based on what the algorithm says. So you're going to see that video tomorrow. If you're a member of the channel, like Reese, you can see the video today. That's one of the perks of being a member. You can see all my videos ahead of time. I usually have 4 to 6 weeks of videos already out there. So if you want to see those, you can become a member, but it's dropping tomorrow. And every day I'm going to be sending out a short that talks about the results from that day. So, and then every week I'll be publishing an update. So am I going to lose money? Am I going to make money? I don't know. But I'm willing to say, hey, I'm a data scientist. I'm going to trust the algorithm and I'm going to do whatever the algorithm says. So we'll see what happens. I'm going to do it for, you know, at least a month, maybe more, maybe less if I go broke. And just do what the algorithm says, right? So I think it's going to be fun. I think it'll be very interesting. So if you guys want to follow along in that series, I think it's going to be really good. And, you know, really looking forward to seeing where that ends up. And then in January, I'm going to be going to CES. I'm going to have some more content coming up around that. Not tomorrow, but the following Monday. I'm going to be going to some of these AI companies and seeing what they're offering. And you know me, I give you guys the real world stuff. I give you guys an honest review. So we're gonna be seeing if there's any good AI companies out there at the show. And then from there, we'll see what January brings. We'll see what the new year brings, right? So those are 2 notes. Oh, I'm sorry. One more note I wanted to share with you. I'm also, for December and going forward, I'm also introducing a new streaming schedule. I'm going to be streaming Thursday through Monday. So Thursday, Friday, Saturday, Sunday, Monday are going to be my streaming days. In other words, I'm taking Tuesdays and Thursdays off the calendar. My analytics say those are my slowest days, and it also gives me a little bit of an opportunity to create more pre-recorded content for all of you, to do more coaching calls if you're interested in a coaching call. And it also just kind of frees me up to do my own personal interests and whatnot. Because, I do have other goals that I want to meet on a personal level. So no streams Tuesdays and Wednesdays, but streaming every other day, 1500 GMT every single day. And there's never a break to the Sunday series. We're going to try to keep the Sunday series going no matter what. All right. So any questions, let me know. Any more introductions, go ahead and put them in the chat. But otherwise, I think we're ready to start. What do you guys think? You guys ready? And apologies for the earlier technical stuff. I mean, I haven't used my equipment all in a week here, so maybe that was part of it. Had my camera died out for some reason, which really doesn't make sense at all. But yeah, so let's get started. Or again, feel free to put your introduction in the chat, okay? So give me just a second to get things set up here. Is everything broadcasting okay on YouTube? For some reason, I'm not seeing it. Okay, it looks like everything's okay on YouTube. All right. So many issues this morning, kind of annoying. I'm really sorry about that, guys. Okay, Reese says everything is well on YouTube. Thank you, Reese. Appreciate that feedback. All right. So let me line up everything I'm going to need. And then we'll get started. All right, part 9 of our series of building a project from the ground up. So we've done a lot of work to this point. In fact, the methodology chart here. So that's the first slide we're going to look at today. So time for feedback. Let me get you guys involved here. You know that the entire goal of our series has been to, follow the essence of data science, right? And as I always say, data science is not a tool, it's not Python, it's not neural networks, it's a process, it's a methodology, right? That's the core of what data science is. So I know a lot of you have attended every single session, right? So where in the pipeline, in the methodology here, do you guys think we're at today? Right? We've done a lot. We've done a lot of exploration on the 3 models that we've identified. But where are we now? Anybody want to take a guess? Give me some feedback in the chat. What step in the methodology do you see ourselves being in? There's no wrong answers here, by the way, right? I just want to get a sense for what you guys are thinking. Because we've done a lot. We've done a lot of discussion, right? We've done a lot of progress into where we're at in our tools. And this is our 9th meeting, right? So what do you guys think? What do you guys think as far as where we're at? I think we've done a pretty good job of keeping both of the selected models, right? Because we have a time series model and then we also have the efficient frontier theory. We've done a pretty good job of keeping those even, right? So I think we're ready to progress to the next step with at least one of the models. But what do you guys think? Give me some feedback. Which one of these steps in the methodology do you see us as being in? I'd love to hear your feedback on that. Let me know. And if you guys, kind of differ from each other, that's okay, right? We can have differing opinions on where we're at. That's also valuable. But let me know. Okay, so Manoj is saying that we are at model deployment. Michael is saying model design, interpret results. And Denelson says, I think we're in our last iteration for model design interpretation results, and now we'll decide which one we will deploy using the visualizations. Yeah, okay. Yeah. Osama says that we're at model deployment. Yep. Anybody else? Last call for answers. Lakshmi says model design and interpret results. Okay. Anybody else? I mean, so far, all the answers are great. And I think that all the answers are accurate. I agree that we're kind of in between interpret results and deploy model, right? Because it's been 2 weeks since we worked on time series. We worked on efficient frontier last week, but it's been 2 weeks since we worked on time series. And I think Denelson is very accurate, right? Where, we're kind of sort of in the later stages of model design and we're kind of getting ready to deploy, right? Because we have done a lot of work on the time series model. We've agreed on the metric to use, right? The MSE. And we saw some promising results, right? We saw some MSEs. And remember, MSEs, you want a low value, right? A low value is a good value. So we saw some MSEs that are very, very positive, right? They show some viability. So I think all of you are right in the chat, right? We've done some model design, we've done some interpretation, we've done the hyperparameter searching, right? We did the champion model process. So we're definitely inching towards deployment. We're inching towards saying, this is the model we want to go with. These are the hyperparameters that get us the best possible results, right? So I think we're on the right track there, right? So I want to kind of, review what we've done to this point. And then we're going to look at the code. We're going to rerun the code as it is, just to kind of remind ourselves, right? Remind ourselves where we're at. And then we're going to go from there, right? Okay, so where we're really at is we're kind of at the point where we need to develop our prediction cycles, right? We need to come up with a prediction code, and then we need to talk about how we're going to deploy. Well, we need to come up with prediction code model, and then we're going to talk about what that deployment looks like from a code perspective, not a hardware perspective, but a code perspective, okay? So here's something, the next 2 slides, really important. If you guys want to write something down, write this down. This is something that nobody really teaches you in school. When you are talking about a data science project, at a very high level, there's 2 very distinct phases, right? Are you talking about your training cycles, or are you talking about your deployment cycles? Those are 2 very distinct stages in a project. And personally, as a manager or as a tech lead, when I'm walking into a new team, I'm walking into a new project, that's the first thing I'm asking. Where are we? Are we in training or are we in prediction cycles? Right? The training side is basically everything you see on the screen. We did our explorations, we found out if things are viable, are there libraries available? And then based on those results, we wrote some code to experiment. We found our hyperparameters, right? We went through the champion model process, and it's basically all the work we've done to this point. But again, that's all training cycles. We're just training a model. we're doing the hyperparameter tuning to try to find the best model possible. The best model being defined by the metrics that we want to use, right? And like I said, we're using MSE for the time series one, right? But all of that is just training. It's an important part of the data science cycle, don't misunderstand me, but it's just training a model, right? It's not that's kind of like what I would describe as like the internal work of being a data scientist or a data science team, right? Because what you're really trying to get to is you're trying to get to the prediction cycle. And the important part here is that this is the code that actually utilizes your saved model that we have created. What did you find in your training cycles as far as your settings, your code, your model? Save that model, and then that becomes what you use in your prediction cycles, right? This is the code that's actually used in future requests. That's why it's called the prediction cycle, because this is what you're using for the unknown, right? You don't have any more training data here. Now you just have a saved model, your saved weights, your saved features, all that good stuff. And now you're saying, okay, give me the answers for tomorrow, or give me the answers for this unseen data set, this data that you've never seen before. Give me the answers for it, right? Like this is like kind of like where, the rubber meets the road, as we say in the US, right? This is where you're actually using it and actually utilizing it for your future business needs, right? Keep in mind that this is also the code that is likely to be used in other programs, other projects. So that's why I keep on emphasizing kind of an object-oriented programming approach. Don't use notebooks, right? Because this code, this piece of code, is what's likely to be used in other portions, other items that you're going to use, right? And also, the important part is that this is also the final deliverable to the client, or to your project members, your stakeholders, however you want to think about that, right? Everything we've done so far, we just agreed is the model code, but that's not the deliverable. That's not what your client wants to see. They want to see the prediction code, right? Because that's really all they care about. They care about, when I need to know the future, or the future categorization, the future projections, whatever it is that your model produces, what code do I execute? And that's what this code is. This is the code that they actually execute to use on a continual basis, right? And again, this is a part that school doesn't teach you, because most of the times, 99% of the time, when you have an assignment or a tutorial or whatever, it stops at the training cycle, right? You develop a model, you write the code, you come up with a confusion matrix, and you turn in the confusion matrix for your grade, right? That's like 99% of courses out there, right? But the prediction cycles is kind of like our end product, right? Like this is what we get paid for. We get paid for to come up with the prediction code, not the training code. The training code leads to the prediction code, but only the prediction code is what's the product, the deliverable that you're actually shipping out, right? In many ways, you should kind of be protective of your model code, because that's kind of like your secret sauce, right? That's kind of like your value add to the entire project, to all of the stakeholders, right? That's kind of like why, you as the data scientist exist, right? But the prediction code is your product, right? That's what you're shipping. This is the software product that you're shipping, right? So that's really kind of, what we want to do here. All right. So where are we with our time series algorithm, right? Just so you guys remember, we're doing a time series for investments. We're using the Profit library by Meta. It's supposed to be a very advanced time series library. So we have a data pipeline. We have a library that gives us a viable approach, right? The Profit library. We've run some training cycles, and there are clear indications that there is a viable approach here, right? We saw in some of the charts that there is a line that shows us the predicted value that profit comes up with, and there's a line that shows us the actual value, the ground truth. And the closer those two lines are to each other, right, the less errors, the better it is for us, right? And the measurement of that is to look at the mean standard error, right? Mean standard error can show you the divergence between two lines, right? So everything we've done shows us, everything we've done with the champion model process shows us that we can come up with some strong hyperparameters that give us some pretty decent results, right? So what we're going to do today, we are going to kind of keep on carrying the ball forward because we are far from being done, right? Last time when we were doing the champion model process, the hyperparameters, we were just kind of viewing results as they come up, right? We were saving the hyperparameters so we can refer to them later, but we weren't saving visualizations and we weren't saving models. So let's do that, right? We need to have saved models and we need to create visualizations along the way. And then we also need to write new code to utilize the model, right? Because once you have a saved model, that's good. We need that. That's part of your product deliverable. But then you need to write the code that consumes that model and actually produces a new result. All right. So that's really what we're going to accomplish today. We're going to, by the end of the day today, we should end up with like the first version, the first iteration of something that we can actually ship, something that we can actually demo, something that we can start talking to the implementation team and say, hey, we might not have the final form yet, but let us send you an example of what we're going to ship to you so that you guys can start your own implementation plans on your end, right? Because as I've said before, it's not really common for an algorithm to stand alone. You're going to be consumed by something else, right? It's going to be used in Salesforce. It's going to be used in like some database application. It's going to be used in some custom application, some ticketing system or whatever, right? So we need to start getting ahead of that. We need to start showing what the deliverable can be. All right. So that's really our goal today. We're going to get to that. We're going to get to the first version, version 1.0 of a product that we can actually ship and say, hey, like this is the first example of our deliverable. All right. Yassine, hello, sir. Late Yassine from Tangier, Morocco. Yassine, so good to see you, my friend. Glad you're here. Hope you're doing well out there in Tangier. All right. So any questions? Anybody lost? Everybody okay? Let me know in the chat if you have any questions. But that's really what we're going to go after today, right? How do we get to that first version of something that says, here is something you can use to make future predictions? Here, Mr. Client, this is what you can use to make future predictions. This is the first version of us proving that we have a viable product for you, right? All right. If you have any questions, let me know. But otherwise, we're gonna start. So let me bring up Visual Studio Code. Like I said, it's been a little while since we looked at time series, so I kind of want to refresh all of our minds. I had to refresh my own mind earlier, just to kind of make sure I knew where I was at. But if you remember, one of the things we did was, we did some cleanup, right? We did some cleanup in our file structure, and now we have data, explorations, modeling, and prediction. So modeling is kind of like that training phase I was telling you about, and predictions is kind of like that phase of where we want to get to, of things that we're actually going to deploy. So if we go to, let's go in sequence. If we go to explorations, we have price collection. And price collection is what goes out to the Yahoo Finance API and pulls down pricing data for some stocks that we're interested in. I think we were mostly focused on Microsoft. So this is pulling down the price, and all we need is the date and the close, right? Because that's one of the features of Profit. Profit says, hey, just give us the date and the close and we'll take it from there. right? That's one of the advantages of using Prophet, that it's that advanced. So that's all we care about. We care about those two columns, okay? And it saves it to a CSV. It goes out and gets it for these 4 items. And that's that, right? Another thing we'll notice is that, again, we try to write programs, not scripts. So the difference here being that we have an entry point, we're pointing it to the main function, and then the main function goes ahead and refers it to a class. Or no, I guess in this case, we don't have a class. Refers it to these basic methods that we've written. And these methods are what go out and run the code, right? But it gives us a little bit of a more organized structure to our data, which in turn helps us, with future usages of this same code. Okay? So we're going to have to, I'm going in order because we're going to have to run this first. It's been a while since we updated our data, right? In fact, let's prove that out. If we go to data and we go to the Microsoft file, you're going to see that our last entry is from November 1st. So in other words, we haven't updated this file in a month. So is a month's worth of data critical? Yeah, sure, right? So this is an older file, right? So it's not the worst thing in the world, but we have the script. We should rerun it and refresh it, right? So that's the first thing we're going to do. And then if you remember, we're in our modeling, we have a time series modeling code. And this is where we basically did our champion model process, right? Where we basically said, hey, these are our baselines. We started off with a baseline of MSE, right? And we basically said, don't print out any results that are less than a 15 MSE, and then reset the MSE so that it always keeps on going lower and lower than whatever the best model was found. So that gave us a champion model as the processing went on. Because as that processing gets developed, we were able to say, okay, yeah, the MSE is going lower, 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 right? And you could see that here in our hyperparameter file. We were logging the hyperparameters as they go along. And we were saying, oh, okay, look, we started with an MSE of 13.9, and then it came down to 13.2, and then it came down to 13.26, and so on until we got down to 12.7. How are we doing that? We were doing it with our hyperparameters, right? So if we go to the class that that ChatGPT wrote for us, we can see that ChatGPT identified 10 different hyperparameters that we could provide values for, and it would tell us which ones were the better ones, right? It would say, yeah, here, this is what you want to be looking at. So by running that type of hyperparameter search, or sometimes referred to as a grid search, you're able to come out and say, okay, yeah, we ran however many thousands and thousands of permutations, and this is the best model that we can come up with. These are the hyperparameters that you want to use for your best model, right? So that would help us kind of keep on lowering that bar for the MSE to try to find the best model possible. And as it was finding those, it was also showing us the charts, right? It was showing us the MSE so that we could have a visual representation of what that looked like, right? All right, any questions? Because what I want to start doing is I'm going to start executing some of this code, and maybe this will kind of help jog everybody's memory on where we were at. But I think I've done a pretty good job of letting us know where we're at. So I want to run the code as it is. We're not going to ask for any changes just yet. But let's just kind of get a feeling for where we're at. I think one of the things we did in our last iteration was we started looking at different values. We started adding some values. So this code might take a little bit of time to run, but it's still going to give us results as we go, right? So it's still going to be valuable. All right, so let's go ahead and start running some of this. So here's my terminal, and if you need that a little bit bigger, I think that's good. If you need that a little bit bigger, let me know. But in the terminal, the only thing I've done is I have our alpha farming Conda environment. It has all the libraries we need. And yeah, I mean, this lets us just start running things, right? So first thing we're gonna do is we're gonna look at our structure. We can see that we have our data folder, which is good. We have our explorations folder, which is good. And that's what we need, right? We need our explorations folder because that's where our code is to update the data, right? So that's where our price collection.py folder is. So let's go ahead and run that because that's going to go ahead and update all of our files, all of our price files. So you can see that it reached out to get the Apple information, Google, Microsoft, and Gold. Pretty straightforward. If we go back to Visual Studio Code, if we go back to that same file that we had, I think it's going to be, is it in this folder? It is. So if we go back here, you can see that now our latest entry is from 11/29, which is great, right? That's the most recent entry because that was the last trading day, right? Today's a Sunday. It doesn't trade on the weekends. You can see that the 28th is missing because that's a holiday here in the US. So we've successfully updated our data for Microsoft and for Google and for Gold, right? You know, they all have, you know, similar entries. The point is that we got the most recent data from 11/29, whereas before it was 11/1, right? All right. So now we're done with our data collection, right? We've executed our pipeline, right? So what we want to do now is we want to go into our time series modeling code. We now want to start running this. And if you remember, what we did was we let it run. And then as the better models were found, they would come up on our screen and we would quickly visually check it, right? So I want to go ahead and do that. So now I want to go to modeling. And then we have our time series modeling file, which is what we want to do. You'll notice that we also have our EFF modeling file. We don't need that today. We're going to leave Efficient Frontier now to the side, but we are going to execute the time series modeling. So let's do that. So now we're going to see this just run, right? And it's not going to tell us anything until we find a good value. And here we go. Remember, our initial threshold was 15 for the MSE. So this here is telling us, hey, I already found you one that's better. It's 13.99. So now, remember, the whole point of a champion model process is to find the best model possible. So you give it a metric, and then that becomes your baseline, and then you're always comparing against that baseline. Can you improve that baseline? That's the fundamental question in the champion model process. Can you improve the baseline? So now 13.99 becomes the new baseline. So the next time the model stops us and shows us a graph, it's going to be because it's better, lower than 13.99. If you're still confused on MSE, this chart helps you understand it, right? Because the yellow is what profit predicted. The blue is the ground truth, what actually happened. So you can see that the MSE is a measure of how closely those values follow each other. That's basically what an MSE measures, right? So generally does a pretty good job, right? Well, I know that in the past, some people express concern about the spikes, right? And here you can see that the orange line, the yellow line, the forecast does a pretty good job of tracking those spikes, right? We're not seeing a lot of divergence, right? An MSE value of 13 is not bad for this type of data, right? But we're gonna go ahead and close this out, and we're gonna let the model run some more. And again, the next time it stops us, It's because it found something better than the 13.9. We already beat the initial 15. Now it's looking for 13.9. And there it is. There's another one. So let me bring that up. So now you can see that this one is 13.3 on the MSE. So that's also pretty good too, right? That's not terrible. So this is going pretty well, right? This is what I mean by us being able to say, hey, this is a viable model, right? Like we're not at the final model, but there's clear signs that this could work, right? Like there's clear signs that Prophet is finding a set of weights that can match up with what's actually happening in the ground truth, in reality, right? So pretty good, right? We're gonna just repeat this cycle just one more time, just to kind of get a feel for it, right? Because now, again, 13.3 is our new baseline. So the model right now is throwing out anything that doesn't meet 13.3. So the next time it stops us, same thing. It's going to be lower than 13.3, and there it is. It stopped us again. So now we're at 13.26. These changes by eye are a little bit difficult to track, but MSE is a mathematical representation of how closely these lines track each other, right? So maybe there's an improvement here in some of the spikes. I mean, I'm seeing an improvement down here, an improvement up here, but the bottom line is that we have to trust that MSE is working as desired, and the weights that are being found are working as desired to help us, create these new baselines. But again, clear signs of life here as far as a viable model goes, right? All right, so I'm going to close this out and I'm going to stop this. I'm going to stop this process because we can improve on this process, right? So let me go back to our code. So you can see here, if we go to hyperparameter results, these are the three values we just saw, right? We saw a 13.99. We saw a 13.29 or 13.3, right? That was another value we saw. And we saw a 13.26, which is great, right? And also, just so you guys are clear on this represents an experiment, right? Each one of these lines represents a successful experiment, because we're saying with these experiments, with these settings, these hyperparameters, we can show that we are getting a viable MSE for you to, have confidence that the predictions that the model is making are matching the ground truth as closely as possible. Right? I mean, that's kind of our job on this one, right? But we can improve on this, right? There's two primary things I want to improve on right away. One, we don't need the process to stop and show us a visualization every time. We were just kind of doing that as a convenience, right? But we don't need it every time. We should save it, right? We're not saving the visualizations now, but we probably should do that. And then the second way that we can help is that we can start saving the models. Remember how we talked about this line here. Remember how we talked about this fit method? You're going to find the fit method in a lot of libraries that are out there, because fit is basically where you're training your model, where you're coming up with the weights. So in other words, the end result of this fit model, the return value, even though we're not tracking it here, the return value is like the model. Like that's where the gold is, right? That represents your saved weights and features. And that's what you want to use in the future. but we're not saving it now, right? We're kind of just throwing it away. So we want to not display, but we want to save the visualization, and then we want to save the model. Because we have nothing to show, we have nothing to create the prediction code with until we have a saved model, right? So we kind of have to solve those two things. It's a slightly complex piece of code, or excuse me, it's a slightly complex prompt that we're going to have to write for ChatGPT, but it's going to make a world of difference. Like, we're about to take the code to the next level, right? Like, this is where we go from, okay, let's stop looking for the hyperparameters. Let's go ahead and start saving these and start using these, right? So just as before, we are going to take this code, use it as our base code that we're going to present to ChatGPT, and then go from there. See where it ends up. All right. So let's start doing that. Any questions? You guys still with me? Let me know in the chat. But I'm going to start bringing up the ChatGPT. But give me some feedback. Let me know you guys are still with me. I know we've covered a lot, but this is where it gets interesting, guys. This is the stuff they don't teach you in school, right? So I'm not surprised that there's a lot of questions, because for some of you, this might be the first time even hearing about prediction cycles, right? Nobody in school asks you to do that, right? So this is our base code that we're going to present ChatGPT with. So we're going to present the code. And ChatGPT usually gives like ideas, which is kind of annoying because I really just wanted to take in the code, nothing else. Okay, so we're going to ask it to save it. And you know what, guys? Just from my own personal experience, I've had challenges with ChatGPT, especially with images. So I try to be very specific. So I'm specifying that I want it as a PNG file. For some reason, ChatGPT and images just don't seem to get along. But since we're asking it for code, I think it'll understand what we want for the output. But just kind of pointing that out, that I'm specifying a PNG file. As new model beats, I don't need you to show me the please have a PNG. When I fit a model, I don't currently save it, right? I want to be specific here. Please add code to save the new model that beats the baseline. And then finally, we also need to modify the log file now that I think about it, because the log file doesn't tell you. Since we're not saving the model, we're not logging a name for the model file either. So we need to log that, kind of like, experiment 1, experiment 2, experiment 3, right? So the saved model name, so that we can. So what we want to do is we want to make sure we have the model name included in the log file, so that when we can say, oh, that's our champion model, and by the way, in the log file, these were the hyperparameters that were used, right? Because you're going to need that information in the future. So I want to specify that also. I think this might be our whole prompt, and I need to specify that it's 3 changes. When the model beats the baseline, don't just show me the please save it as a PNG file. Second, when I fit a model, I don't currently, come on Dennis, I don't currently save it. Please add code to save the new file that beats the baseline. Finally, please add an ID that reflects the save model name so I can refer to it in the. Okay, I think that's good. So let's see what it comes up with. All right, so it's saying it's save the visualization, save the model, and add a model ID, model results CSV. Okay. So let's wait for this to finish rendering. So right there, we can see that it's going to use the pickle library, right? The PKL is usually a pickle extension. So it's saving the model as a pickle. It's saving the image as a PNG. There's a model ID that's being added, which is fine. Yeah, and yeah, you can see here there used to be a plot.show that would bring up the chart, but now it's just telling us that it saved it. So this looks pretty reasonable so far. Is that finished? I think that is. So let's go ahead and do that. And then we're going to put that back into our Visual Studio Code. All right, so let's take another quick look at this. Yeah. So here you can see it's no longer doing a plot.show. It's just doing a save figure instead, which is what we want. It's then telling us where it's saved. So I think it's handling the PNG okay. And then here, you can see that there is a model and an ID number that's being added. So which is good because we want that. We want that to be able to let us know. Well, it's going to give each model a unique name, right? Because you don't want to overwrite the file. You kind of want to see the progression, right? But this looks all fairly reasonable. Let me look down here because I think it's expecting a new, hyperparameter results, file path. And then initial baseline is 15. We're still going to do 15. Excuse me. So I think everything is pretty reasonable. But this model path does kind of catch my eye. Where is model path being set? Is that one of the class values, I'm guessing? Yeah, model save directory is saved models. So in other words, it's going to make a new directory called saved models. And that's okay, right? We kind of want that. But yeah, everything looks pretty reasonable to me. So let's run this. So a couple things we're going to see, right? Now, when we run this, you'll notice that we don't have any subfolders. So this is going to create the subfolder saved models. And then as it progresses, it's not going to stop anymore. As it progresses, it'll just add different models into that directory. And then, so we'll be able to monitor it, not from the terminal, but from Visual Studio Code. And we'll see those new PNGs come up, which is good, right? That way the code can run and we'll just use the latest file, okay? All right, let me check the chat real quick. I think I got some feedback in there. Yassine says, I'm with you. Thank you, Yassine. Denelson says, very clear. How long do training cycles usually take in a real setting? Denelson, it depends. It depends on the number of hyperparameters and the number of values that you're testing for those hyperparameters, right? Because then it's just a math problem, right? It's permutations, right? It's n factorial times n factorial times n factorial, right? That gives you the number of permutations. And then also it's a function of your processor, right? Are you on CPU and GPU, a good one, a bad one, locally? Are you on dedicated hardware, right? So there's really no telling, but you want to let it run as much as possible. And so that's why I always say, you run every permutation or until you run out of time, right? The stakeholder, tells you time's up. But again, this is why we want to log it as we go along, because sometimes you'll just have to say, hey, we know that we haven't finished, but this is a good enough model for us to continue with, right? And we might do some of that today, right? But yeah, Dental Senate, there is no single answer. You just kind of want to keep on going as much as possible. All right. All right, so I think we're ready to run this. There's no change to our execution code, so we really are going to run the same file. All right, so we're going to let this run. Terminal's not going to stop. And the changes should be in VS Code. So again, we're looking for a new folder to be created. Oh, there it is already, saved models. And there's a model already, guys. So model 1, there it is. There's the one we saw previously, right? 1399. There's another one. It just appeared. So there's model 2, 13.32, and so on and so on. It'll just keep going, right? So I'm really happy with the code that ChatGPT produced. It got our desired result in one shot, which is great, right? We want that. All right, there's model 3. So model 3 is 13.26, which is what we saw earlier, right? So this is great, guys. There's model 4. Model 4 is 13.05, right? Now, if you guys remember, we're, kind of coming back to Denelson's question, we're using a truncated version of the permutations available, right? And we're doing that because, for the sake of the stream, right? Like I told you guys, some of these phases I'm compressing just to kind of keep us moving along, right? But this is what you would do in real life. Like this is what you're monitoring from now on, right? Like, you as a data scientist, you're letting your code fly and you're just basically sitting and saying, okay, what does the logs or the progress tell me? Because this could be a multiple day process, guys, right? You could be running your search for like days and days and days. And all you're doing is just monitoring your PNGs or your new available file, right? And if we go back to our methodology, we're here, right? We're at a visualization and deploying model stage. Because guess what? This pickle file that you're seeing, even though it's not viewable because it's a pickle file, that's your product. Like this is your product. This is what we've been after. This is what pays the bills, right? Getting to that save model is what you want. So that's why we're now squarely in this later phase. We have some visualizations to prove out our tests, our experiments. And now we have a model. We don't have a way to use that model yet, but we're going to get there, right? But like this is it, guys, right? This is what you want. You want to get down to those pickle files and those PNG files, because this is what we turn over to the stakeholders. Here's the model. Here's how you use it. Here's a visualization that shows what your potential results could be going forward. Or this is our documentation to show why we have confidence in this model. Right? Pretty cool stuff, guys. Pretty cool stuff. So let me know if you have any questions, but this is where we can work in parallel. And again, like I said, What I'm showing you guys is a process you could be doing for days and days and days on end. But we don't have that for a stream, right? So what we're going to do, and what you may do in real life too, because you're not going to be sitting on your hands when it's running for days and days, is you want to front run the next piece of code that we're going to need. And that's where we're coming back to needing the prediction cycle code, right? Because we don't have that yet. How do you take this pickle file and use it for tomorrow's data? We don't have that yet. But we can get there, right? We have an employee. Employee is ChatGPT, right? And that's when we're going to switch folders. If you remember, right, as we talked earlier, we have a modeling folder and we have a predictions folder. And we created this file as a placeholder. But there's nothing here, right? But we need something here. This time series prediction.py is part of our deliverable, right? So we're going to leave this terminal running. Oh, did that already finish? Oh, okay, that already finished. Cool. Okay, that means we could probably afford to run a lot more hyperparameters, because that finished really fast. So let me go back and do that. Hey AJ, hey Leo, welcome. Glad to see you guys here. All right, let me go back and add some more hyperparameters. All right, guys, just so we're clear on what just happened. Remember, as I said, we're using truncated versions of the hyperparameters. And again, coming back to Dennelson's point, how long is this going to take? Well, it's a function of how many values you're testing. So here, you can see that in this one, in the change point prior scale, we're doing a pretty good job of dispersing the values. But in some of these, we're not, right? Because, you know, I only have so much time on the stream. But since we're going to work in parallel and let this process run while we try other things, there's no harm in us saying, hey, let's let this fly while we do other things in the background, right? Totally okay to do that, right? So let's start adding some more values. So here we can add a 7 as an in-between. We can add a 2 as an in-between. And, you know, there's no magic to this. We're really just trying a variety of different values, right? We're just trying we're trying different values because each value represents a permutation of an experiment, right? And more experiments, more better, right? So here we can add a 15. We can add what, like a 35. And I think that's good for now. I think that's good for now. Again, no magic to it. We're just trying to get more permutations. And just as before, just like we talked last week about the efficient frontier, right now, where are we? Right now, our baseline is Model 5, and Model 5 is showing us an MSE of 12.7. So that's the first time we've seen a sub 13 MSE. And remember, MSE, the lower the better, right? We want it to approach 0. A 0 MSE means that the two lines are in perfect lockstep with each other, right? So we want to approach 0. So same question I gave you guys last week. Are we likely to find an MSE or a metric that's going to be lower than our baseline? Like, yes, we are, right? Like you don't get caught up in, oh, well, it's Microsoft stock, or, you know, they have earnings coming up, or I heard this. That's not our role, right? The data science view says, well, we've increased the number of permutations. We've increased the number of experiments that we're going to run. So the smart money is on saying, yeah, we're probably going to find something better. Not guaranteed, right? But on a permutations basis, the more of a grid search you do, the more likely you are to find a hyperparameter combination that works or that improves your baseline, right? I mean, it's just a probability basis, right? Denelson says, for parameters that are numerical, could we use a randomizer with a range, or would the manual input of the values work better for initial runs? Yeah, great question, Denelson. So Denelson, I don't know if it was you or somebody else that asked a similar question. But here's the part that I'm not necessarily showing because, again, you know, there's only so many things I can show here, right? You know, because of time constraints. But what you want to start doing is you want to start tracking your log file. And your log file gives you indications, right? So for example, here, you can say, okay, I ran this search and look at that. For my second value, my change point prior scale, I'm definitely skewing on the higher side, right? 0.6, 0.75, 0.9, right? So that could guide you. And you could start saying, okay, well, instead of taking these big jumps, I'm going to make my low value 0.6, and then I'm going to take smaller jumps. 0.65, 0.67, 0.7, 0.72. And then that way you can kind of start to converge on some of those values, right? Nothing else jumps out at me. Okay, here you can see in the, what is that? The yearly seasonality. What is that second to last value? The change points, the number of change points, right? You can see that all of them have the value of 50. So maybe change points is skewing also on the higher side. So you don't want you want to try a little bit below 50 and a little bit above 50, and then start seeing from there, are you going higher or lower, right? And then that kind of guides you a little bit more. The point being that the champion model process isn't a single run. You can use previous runs to help guide you and help, you know, make better informed decisions on your future runs, right? As far as your initial runs, yes, you can use a randomizer if you really wanted to, but really the only thing you want to know, and if you remember the prompts, I just want to know the range. Just give me a valid range for those values, and then I'll do the low, I'll do the high, and then I'll pick things in the middle. And then kind of, you know, let myself be informed from there, right? But for your initial runs, you just want to make sure you're hitting the range. And then you kind of go from there. So I personally have never used a randomizer. I think it's a little bit overkill. It's more about just saying, what are my valid ranges? And then can I just like make informed decisions based on previous runs? All right. So I hope that makes sense, Denelson. All right, so what did we do? We increased our parameters here. And actually, we just talked about 50 change points. So let me go a little bit higher on that. Let's go to 75. Because clearly 50 seems to be a key number. So what does it look like above and below, right? So I have 35 and 75. So actually, I could delete some of these, right? Because it's clearly at least 50 or in the 50 range. Let's see what this gives us. Yeah, but otherwise I think we're ready to run this over again. And same code, just more parameters, more permutations. That's all we're doing. So we can still monitor the save models folder, and we know that our current champion model is 12, or our current baseline is 12.72. So now we wait. Now we wait to see if we can find something that beats that, right? Okay, so I talked about working in parallel. And this is something you're going to be doing, right? Because we just kicked off a process that could take days and days and days in the real world. Let's go back to ChatGPT. What we need now is we need code that takes that saved pickle file and uses it. Because I want to make predictions for tomorrow, right? I don't want to just train the model. I want to make predictions for the future. So let's do that. Saved model file, I need to specify. Make prediction for the next 5 days. We'll specify 5 days. And then please make sure it's a program with a dedicated class and a main method entry point. And I want it to be a new Python program. Use the model to make predictions for the next 5 days. Please make sure, okay, I think this will work. Okay. I should have said earlier that I was expecting a short file. And, you know, this does seem a pretty compact file. So now we're going to go to our blank time series prediction, and this becomes our first iteration. So just as before, we have a main method, or excuse me, we have an entry point for the main method. We have our main method. The main method picks out the model file. It goes to that save models folder. It goes ahead and loads the model. It uses a predict future method that it wrote, and then it outputs the predictions. That's fairly straightforward, right? Let's look at the class. So the class initializes, takes the model file. It initially starts with no model because it hasn't loaded a model. But it does that here. It loads the model file, puts it into the model parameter, and then it uses it to predict. So here is the key line, guys. Right here is the key line. When you see the dot predict, that is the actual call to the Prophet library, the method within the Prophet library that actually creates the prediction. Right? Like that, this is the you know, kind of like where the heart of the call is, right? So that is the difference, because previously this would have been a call to the fit method, but we're no longer in training. We don't need a new model. We have one. We want to save this model, right? So instead of fitting, we want to go ahead and say, here, let's use it, make a prediction. And we specified we want it for the next 5 days. And we can change that, obviously, right? But I want to point out that this line here, line 28, is this is where your money is, right? Because this is where you're actually saying, I'm done training. This is a good model. My champion model process tells me that this is a good model. So use it, right? Tell me the future, right? Or categorize my items, or do this, do that, whatever it is that you're asking your model to do. It's the predict method that does it, right? And then it goes ahead, it returns the future predictions, and yeah, I mean, that's basically all there is to it, right? So we do need to make one change. We know that this exists in a different directory, right? So we need to go up one directory, because we're in predictions, and then we need to go to modeling, and then it should be in save models, model 1 pickle. But we know that model 1 is just a placeholder that it used. So here is where we would put in our most current model. Visual Studio Code is telling us that it's still on model 5. It hasn't found a better model than model 5. So that's what we're going to go ahead and use. We're going to modify that to use model 5, the model 5 pickle file. And that's it. That's all we need. Yeah, that looks good, guys. All right, so let me refer back to the terminal. So the terminal is still running, right? This is still our champion model search. We've given it a lot more parameters, so this is going to take a lot longer to run. But that's okay. All we need to do is open up a new terminal file, right? So let me go ahead and do that. Give me just a second, guys. I want to open. All right, so there's our new terminal. We can run terminals in parallel, right? There's nothing wrong with that. Let me make that bigger for you guys. If you need it bigger, let me know. But you can see here, we have our time series prediction, which is our new file, right? So this is good. I need to activate the Conda environment. I haven't done that. So let me get that. We only need to do this because it's a new terminal window. There it is. So we're going to activate alpha farming, and we are going to go ahead and run this now. Python time series prediction. So this is brand new code, guys. We haven't run this before. All right, and there we go. So, ooh. All right. So we have an error, but in theory, this works, right? It's showing us what it thinks are the next 5 days. And remember that Y hat shows us the predicted value, right? So profit gives us Y hat upper, and Y hat lower. And both of those represent the range, right? The upper and lower bound range. And then Y hat represents what it thinks the actual value is going to be. So this is telling us that on 11/2, it's expecting 338, 330, 375, 365, and 354 is the pattern that it sees for the next 5 days. So if tomorrow was 11/2, you'd want to use just this value, right? Or you could make future projections and, use future values depending on the type of trading you do or the different applications you could use this for, right? You could do 1 day, you could do 10 days. We're just choosing 5 days. However, there's a problem here, right? And the problem is that, remember how we looked at the data files previously? It's using those data files for the projections. It's not successfully using the most current files that we gave it, right? So we have a mistake here, but this isn't ChatGPT's fault. This is our fault for the way we've structured the folders. We are training the model on older data. It's not using the most current data possible. It's training on the files that were last updated on November 1st instead of the files that we updated today that were current as of November 29, right? So I'm glad we ran into this because it illustrates how careful you need to be when you're managing these data files. We kind of tripped over our own shoelaces in this scenario, right? Because you can see here that, profit thinks that the current date is 11/1. So it's giving us the projections for 11/2, 3, 4, 5, and 6, which is the next 5 days. So the ChatGPT code is correct, but our management of the data files is not correct. So let's fix that. We can definitely fix that, right? So let's go back to Visual Studio Code. I'm going to go ahead and call the time series prediction code correct. The time series modeling code is correct, but we will have to rerun this. So actually, let's do that. Wait, let's let it run for a bit. What we really need to fix is we need to fix our data collection files, which is in our exploration, and it is here, price collection. So the problem is that price collection is saving here, whereas before we were saving in the data folder, right? So if we go into our explorations folder and we look at the Microsoft file in here, this is the one that we updated today. You can see that the last entry is 11/29, which was this past Friday, which was the last valid trading day. So everything looks good there, right? No reason to believe that that's wrong. Where it's not correct is in the data folder. If we go to the Microsoft file in here, the last entry is 11/1. So that's where the problem is. So this tells me that our model is training on the data in the data folder, not the explorations folder. So that's a mismanagement on our part of the data files. And that's okay, right? We can fix it, right? So how do we fix it? It's tempting to just copy over the files, right? We'll just replace the CSVs in one folder for another. That fixes it, right? But does that fix our data pipeline? It doesn't. Because remember that this file, price collection, effectively represents our pipeline. Right? Like that is our pipeline. Like we're going to deploy this because we need to run this on a continual basis, right? So this file needs to be fixed. And it's going to be here. Yassine says we can change the path used in the code. Yeah, that's exactly right, Yassine. That's what we need to do, right? And it's right here. You can see where it's being saved. So here you can see it's being saved locally, which is not the worst thing in the world, but it's a mistake. It's a mistake in our pipeline, in our data pipeline code. So we can fix that pretty simply, right? We want to make sure that it's sending it to the data folder. That's the mistake that we made. We were saving it to the local folder instead of saving it to this folder. And we can also verify that because if we go to time series modeling, if we go to the stock data, stock data is down here. So that's the problem, right? This path is a valid path, but it's not our latest files. But now we've synced up so that our pipeline is also saving to that same path. So that's a mistake. So let's go ahead and fix that. So we fixed the file, we fixed the pipeline. We just have to rerun it, and we can do that, right? If we go here, and then we go to the code, we got to go to explorations, and then we got to run price collection. And then we go to, yeah, so that's good. So now let's go back to VS Code. So before in VS Code, if we looked at the Microsoft file, the last date was 11/1. But if we go now Now we're back to good. Now we're at 1129, which is where we want to be. So that means that both of our Microsoft files, both in the data folder and in the local folder, both represent 1129, which is good, right? We want that. Okay, so question for the chat. Are we done now? Like, are we done? Is that the only change we needed to make? If I go back to the predictions folder and I go ahead and rerun time series predictions, what are we going to get? Let me know in the chat. Give me a 1 if you think we're done with the changes. Give me a 0 if you think we're not done with the changes. What do you guys think? Do we need anything else? A 1 if you think we're done, right? When we run time series prediction, it's going to be just fine. Or give me a 0 if we're not done yet. AJ says, still need to fix the y-hat problem. Which y-hat problem? What do you guys think? Just give me a 1 or a 0. If you want to add a rationale, you can. I'm not going to call on anybody. But are we done? What do you guys think? Are we done? Feels like we're done. But maybe not. Okay, Yassine says we're done. You can just say I agree with Yassine, right? Denelson says 0. We still need to add in the visualization. Help me understand that rationale. I'm not sure if we need a visualization, Denelson. But we got a 1 and a 0. Anybody else want to vote? 1 if you think we're done, or 0 if you think we still got work to do. What do you guys think? AJ says 0. Manoj says agree with Yassine. Okay. Last call for votes. Last call for votes, and then we're going to execute this code here. Rex says, I don't know. Hey, you know what? You know what, Rex? That's a valid answer. A valid answer. Okay, Michael says we're done. Osama says we're done. Okay. All right, so let's run this code. Same call we did before, right? Yassine says everything worked fine using the previous file and data folder. Since we changed that, everything should work fine, I guess. Okay. My thinking is the client would feel better if they had visualization and prediction with the upper and lower bounds. Okay, Denelson, but that's a different challenge than what we're faced with right now. I want you guys to take a look at what's up on the terminal. Are we done? Yassine, Manoj, Michael, Osama, you said we were done. But what does that result say? Are we done? Yassine says wait. Oh, I'm waiting, Yassine. I'm waiting. You let me know if we're done. What happened here, guys? Ah, there you go, Yassine. Yassine is asking, did we retrain? Spoiler alert, we did not retrain. So I'm using this as an exercise to show you guys. The data is baked into the fit function. Because remember, at this point, we're not using any data. The prediction cycles do not use data, right? Let's look at that code again. This is our prediction code. Show me the call to the data. There is none, right? There's a call to the model method, right? But the data is baked into that model. Remember, algorithms are not sentient beings. Algorithms don't know what day it is. They just know the data that you gave it. So, yeah, we need to retrain. So for everybody who said we were done, wrong. We need to retrain. We need to give the algorithm knowledge of what day it is, what the latest data is. It has no knowledge of that right now. And by the way, guys, this is why you create functions. This is why you create programs. Because retraining models, rerunning data pipelines, that's not a one-time thing. That's not a one and done code. That's not a notebook you just execute one time. You'll be writing scripts in like Linux command scripts, like bash files, to help you do this on an automated basis. You can't do that with a notebook, right? But yeah, the data, the latest, and by data, I also mean the latest dates, right? What day it is today, what predictions I want you to make, it's baked into the model. It also means that all of these models that we had before are invalid. They're essentially invalid now, right? Because they were using month-old data. You can see that we've had some new additions. Model 7 is, wow, 8.85 MSC, which is fantastic, but completely invalid. We need to start from the beginning. We need to retrain. All right. So let me start that, and then we can talk about this a little more. Let me know if you have questions on that, but I'm going to restart it. But if the current status is not clear to you, let me know. All right. So where are we? Okay, that's not what I wanted. Oh, I know what it is. Okay, so the modeling function's already finished, which is great, but invalid, right? So one thing I want to do is I want to clear out all of this because these are basically no good, right? So I want to go ahead and clear these out. And by the way, it's great to see that we were able to finish even with the new parameters. So I want to go ahead and delete all of those. So saved models is empty now, right? We have nothing in saved models. And we have our terminal. So here's our terminal. We're not going to do anything different. We're just going to rerun the same file, except we have updated data now, right? And because of that, we should be expecting completely different MSC values. We just added a month's worth of data, right? The odds that the MSC values would line up equally are not likely, right? They're going to be in the same ranges. I'm still expecting low MSCs, but we could be above 13, below 13, who knows? All right, so I'm just going to rerun the same code we just ran. And just as before, we're going to monitor save models because the new models, the new models and the new PNGs are going to start popping up here. Okay, there we go. Model 1. Oh, wow, look at that. Right from the start, Model 1 is a 12.69 MSC. That's not bad, right? That's a better initial model than we were getting before. If you remember, our initial model before was like 13.9 or something like that, right? So right off the bat, you can see the changes, the benefits of the additional data. So right from the get-go, we're not doing too bad, right? Like pretty good initial start, right? Yeah, so now we're just going to wait and see what happens. There's Model 2. Model 2 is at 12.2. So we're getting better information already. This is great, right? Okay, so again, working in parallel, we can go ahead and go to our time series prediction. We don't have a Model 5 yet, but we have a Model 2. And Model 2 is already better than our previous Model 5. So I say we continue with this. So that's one terminal. Let me go to, okay. Okay, so here is the same code we ran previously, but now Now we're on track, because now we're looking at completely different dates. Look at that. We went from an 11/2 projection to an 11/30 projection to 12/1, 12/2, 12/3, 12/4. Now we're on the right track, right? Now we're doing good stuff. So now you can see that the projections are completely different. And by the way, I know that some of you are going to notice why the numbers are so different, 345 to 437. That's because Meta takes in the seasonality and the seasonality within the weeks, right? 11/30 and 12/1 are weekends, so those prices aren't accurate. But for Monday, if you were to execute on this information, this is the information you would use, right? Because you want the 12/2 value, because profit in the background takes into account the differences between what happens on a Monday versus what happens on a Saturday and Sunday, right? So these are the values that you'd want to use. You want to use it for the actual date that you plan to execute on, right? But this is the value that we'd be looking at for Microsoft on Monday as the predicted value, right? But you can see there, right? Now the new data, the latest data, is baked into the model so that we are accurately reflected what the last trading day was and what the next upcoming trading day is, which is, Monday, December 2nd, right? So I want to do something just out of curiosity. I bet there's a new model available. Yep, we're already up to Model 5. Model 5 is now down to a 10.8 MSE. So we've never seen a sub 10 MSE, but we're headed in that direction, right? You have to believe that a sub 10 is possible, right? So now let's go ahead and change that. Let's use Model 5 instead of Model 2. And let's rerun it. And I'm curious, here's what I'm watching, guys. I'm watching this line. We're going to get a very similar output, right? But in the sense that we're going to get these 6 lines, right? But I'm watching this line to see how much more refined this value becomes. We've gone from a 12 something MSE to a 10 something MSE. So in theory, this value here should be a lot more refined, right? By how much? I don't know, right? But it'll give you an idea of the scale that's involved in an MSC that's good enough versus an MSC that's refined or more refined, right? Just because it's refined doesn't mean it's at 0, right? But let's see what happens here. Okay, look at that. Wow, that's crazy. So previously at a 12 MSC, it's telling us that Monday, it's going to be at 437 and 3 cents, 4 cents, right? But with a 10 MSC, it's telling us it's going to be at 433 and 92 cents. So in real world dollars, that's a $4 difference, right? So again, going back to our our fantasy example, to a company, a finance company that is going to use this, that is dealing in orders of thousands and thousands of shares, tens of thousands of shares in a lot of cases, especially for a big company like Microsoft, that $4 is pretty darn significant, right? Wouldn't you agree with that? So I'm glad we were able to try that, because you can see how the different refined MSCs, kind of a big deal, right? A $4 difference per share, and you're dealing in tens of thousands of shares. That's not a small difference, right? Now, obviously, I'm assuming that the model is correct. The MSC is an appropriate metric. I think it is, but kind of gives you an idea of like why we go through this. 12 MSC is not bad, but look at what we did at 10.8. What if we could cut that in half? What if we got down to like a 5 MSC? Like how much different is that going to be from our previous results, right? That's crazy. That's a huge difference, right? So think about that, guys. Very, very valuable to go through all of the different experiments. Run as many permutations as you possibly can, right? Very healthy exercise to do that. Very good reasons to do that. All right, so let's go back to our code. Let me go back here. Yassine says, is there a reason why we compare the value for the third day exactly, or it could be any day? Yassine, we looked at the third value because that's the next trading day, right? Remember, just so everybody remembers, in our hypothetical scenario, we've been hired by a finance company that wants to find alpha. So we're using data science to help them find alpha, help them find excess profits, right? So we're dealing with the stock market, the US stock market, and the US stock market is generally only open Monday through Friday. There's plans to change that in the future, but Monday through Friday. So Profit doesn't necessarily know that. So it's going to give you predictions for every day. So we were looking at the third line because that's the date that represents Monday. That's what we were doing that, you see. Okay? Excuse me. Okay, guys, just for even more fun, if we look at VS Code, we were using Model 5, but look at that. It's come up with a Model 9 now. And Model 9 is a 10.5 MSE. So that means we've gone from 10.8, I believe it was, 10.8 to 10.5. Now that's interesting, guys, right? Two things jump out at me. One, I want to see how further refined this prediction is if we use Model 9. And two, that's 4 additional iterations from 5 to 9. But look how small that difference is. It's a difference of 0.3 in the 2 MSEs. So that tells me that we're kind of converging on an answer, right? Because if we went 4 iterations, 4 new champion models, but we've only progressed 0.3 in the MSC, you're kind of converging, right? Maybe we're approaching some limit on how much better we can improve. So again, Denelson, coming back to your question, how long does it take? Well, if you could come up and say, well, look, we ran 10,000 permutations. We seem to be converging on 10 something MSC. Is it worth it to continue, or are we good enough? Right? So these are the conversations you start to have with the stakeholders, with the teams, with executives who are going to kind of help you with those decisions and say, well, look, we're obviously, hitting some sort of a tipping point. So why don't we just stop here? Or why don't we declare this the champion model? You can make educated decisions like that, data-informed decisions like that to determine when you're done. Okay, Denelson? So just to give you that idea, right, you can kind of start to see where it's headed. You use these runs to inform your decisions. So there isn't always a clear finish line. Ideally, you want to try every permutation possible. It's possible to do that. But from a practical perspective, you make adjustments, right? And there's nothing wrong with that. All right, so let's use Model 9 and let's see what we come up with. So we were using Model 5, and now we're going to use Model 9. And remember, this is a 0.3 improvement on MSE. Previously, we were looking at a two full points of improvement in MSE. But now this is 0.3 improvement. So we'll run it again. Okay. So here's the result for Monday, right? 12/2, because coming back to Yassine's question, that's the next trading day. So that's why we're using that. So now it's an additional refinement. It's an additional refinement of $1.50, right? We were at 433. Now we're at 432.96. So again, if you're dealing in tens of thousands of shares, knowing that there is an additional $1.50 improvement, pretty darn valuable, right? And we've only gone 0.3 MSE. That's pretty crazy. You know, I really hope that that's coming across on how impressive that is. Because to me, that's like fascinating, right? That the MSCs have those differences, right? Or as we talked earlier, have we increased our chance of improving? Yes, because we're doing more permutations. And this is why you want to do that. You want to have as many permutations as possible, right? So I'm really kind of glad we walked through this, right? And if you look at this one versus our first test had us at 437. So that's what? That's $4.50 improvement over the initial model. That's crazy. That's excellent. All right, going back to the code again, because there's still something else I want to talk to you guys about. So you'll also notice, and I'm going to close some of these out so we can focus exclusively on prediction. You'll notice something else. You'll notice that I specifically asked ChatGPT to give us the predictor as its own class, right? And the reason I asked for that is because remember how I keep on telling you guys, you can't deploy a notebook? Or I tell you guys, you should try to study object-oriented programming. Or I tell you guys, that your algorithms are going to be consumed by something else, right? Writing your code like this and putting it in its own class is what makes it consumable by other items. You're handing over a class that another person, another team, in most situations, they're an IT team or like a traditional DevOps team, a software engineering team. This is where they take over. And to them, when you hand over this code as a class, it's no longer data science code to them. To them, it's just another library that they're working with. Just like any software engineer has done, hundreds of times in their career. So in my book, I referred to this. I referred to how most data science projects, when executed properly, end up looking like most software development efforts. Because software developers, software engineers, your traditional software engineers, they use libraries, right? They make calls out to libraries. We have just created a library that a software engineer can use. This is why you want to design them as classes. Because now you're saying, hey, look, I'm not going to teach you the algorithm. You don't need to know what's going on behind the scenes. The only thing you need to know is that here's my file. The class is called stock price predictor, and you want to call the predict future method. That's it. So when I tell you guys, they shouldn't care whether it's an algorithm, a neural network, or a room full of monkeys. This is how you do that. This is how you're creating like that DMZ between your work as a data science team versus like a deployment team or a DevOps team, an MLOps team, whatever, right? To them, it's just another library that they're using. Or in some cases, you'll take this and you'll put it behind an API layer. And then the API layers can be used by anyone and anything, right? Assuming a REST API, right? But this is kind of like where we're jumping the shark into saying, well, yes, we're a data science team, but you don't care about that. You just care that here's the library and this is the method I want you to call, right? You would document this in some way, right? And call and have them do it. Or in some cases, I've done it as pair programming. where I'll actually sit down with one of the software engineers and I'll tell them like how to hook it up, right? How to create their own pipelines into their own software. Because it's unlikely that somebody would run this as an independent program. You'd be sucked into something else. And that's okay. That's totally standard, right? But I kind of want to use this to illustrate that, because again, schools don't teach you this, right? There's no tutorials out there. Even like the quote unquote best online courses, which is an oxymoron, don't talk about this, because this isn't really needed, or they just don't know any better. But you really wouldn't know this unless you're out there in the real world, right? But this is kind of what I mean by that, where every step after this, after you hand this over, like you should be talking in software engineering terms, not data science terms. If you've done a good enough job to package it as a single usable library, then the people down the line, the IT guys, the software engineers, all those guys, like they don't care. Like monkeys could have written this code. They don't care. They just tell me the class name and the methods I need and my expected values on return. That's all they care about, right? So I hope that's coming across here, guys, because super important. If you guys can show up on your first day in a job and you already know this, they'll love you. All right. So I think that's it. I think that's it for today. I think I've hit all the points I want to hit, because here's where we're headed with this. This file, time series prediction, what's up on my screen right now, is our product. Like this is our final deliverable to the client. When we hand this over, we fulfilled our job to the client, right? So that's really kind of where I want to get to with this in the bigger picture. What is our finish line for this project? This is it. Completing this file is our finish line. And then I think it was Denelson that asked in the previous session about creating an article about this. And that'll be the final session, our final step, right? But what we've done today is essentially a representation of what we hand over. We're not going to hand over the training code, because that's our lab, right? That's us doing our experiments. We can refine it further. We can try more hyperparameters, right? I mean, we would want to spend some time with this file, right? Because this file, kind of helps guide us a little bit more, right? I mean, you can see here that we had 3 results at 0.9 on the change point prior scale. So maybe we want to explore that value a little bit more, doing more experiments. But we're at a pretty good point right now where we can say, hey, we kind of have a viable product here, guys, right? So this is where we're going to pick up next week of, well, what now? Like, what are we going to do now? Right? So that's where we're going to pick up next week. But this is where I think it's going to get really exciting, as far as like, okay, we're reaching a finish line, right? We're getting there. So, yeah, I think that covers everything I wanted to do. I'm running through my mental checklist, but I hope that you guys are leaving with that impression of how important the time series prediction file is. Because this is our final product. And it's only 59 lines. There's a couple of double spacings in here, right? So it's probably even shorter than that, but it's like 50 lines, right? We have some important imports, right? The profit import and things like that, right? But this is it. This is it, guys. This is our deliverable. How it was created, who cares? The client doesn't care, right? Your managing director is not going to care. They just want the deliverable that can be used by Salesforce or by their custom website or whatever, right? And this is it. This is what I promised you guys where I wanted to get to. This is version 1 of here. Here's our model. Try it. Here's our model. You want to type in this to execute it and go. But this is version 1 of our intended deliverable for the client. So credit to ChatGPT for really not making any mistakes today. The mistake we ran into today was human caused, right? Kind of speaks to the importance of making sure your paths and all that are working well. You know, that was kind of the failure today. But this is it, guys. So congratulations. We have a product. We have our first version of a viable product. I think we've done great. And we did it in a compact 2 hours. So sorry about the earlier mistakes with the tech stuff. That was kind of annoying. But any questions, let me know. But I'm glad that we did this. I'm really hoping you guys walk away with that importance of the prediction cycles. This code is significantly different than the training code, right? I mean, half this code is just loading the model, right? So really good stuff today, guys. Really good stuff today. All right. So again, I'm changing my streaming schedule. I'm intentionally including Mondays so that you guys can come back and ask questions about today. So, think about this overnight. Maybe you want to watch the replay, whatever. Think about this tonight and then come with questions tomorrow. I'm off Tuesdays and Wednesdays, and then I stream Thursdays through Sundays. Next Sunday, we're going to move on and say, okay, well, we got our product. What do we do with it? We've got at least 2 more sessions, right? So we'll pick up there next week. So as always, please, lots of craziness going on in the world today. So take care of yourselves, take care of your families, and I'll see you next time.